Question 16. The force F equals 2I minus J plus 3K acts at the point -3, 1, 2. Find the moment of the force about the point B, 2 to -1. Then find the length of the perpendicular from the point B to the line action of the force. Solution. We have the point F of coordinates 2, -1 and 3 passing through the point A, -3, 1 and 2. The required is to find the moment of the force F about the point B. First we calculate MB. MB equals BA cross F, but we don't have BA, so BA equals A minus B, the components of A minus components of B, which equal -3, 1, 2, such that A equals -3, 1 and 2 minus B. B equals from the given 2, 2 and -1, 2, 2 and -1, which equals -3 minus 2 equals -5, 1 minus 2 equals -1, 2 minus -1 equals +3. So we have BA equals -5, -1 and 3, and the moment about B equals BA cross F, and we can calculate it using determinants. So MB equals IJK, -5, -1 and 3, -5 and -1 and 3 is the components of BA. BA equals -5, -1 and 3 cross F in the third row of components 2, -1 and 3, which equal -1 multiply 3 minus 3 multiply -1, -1 multiply 3 minus 3 multiply -1 I. We know that the sign of the cofactor of J is negative, so we write negative, and the value of the cofactor of J, which is -5 multiply 3 minus 3 by 2, -5 multiply 3 minus 3 by 2, J plus -5 multiply -1 minus 2 by -1 K, -5 multiply -1 minus 2 multiply -1. It is the value of the cofactor of K. Note that the sign of this cofactor is positive. By calculation, we find that -1 by 3 plus 3 equals 0, I. So we don't have I here. And the -5 multiplied 3 minus 6, it is -21. -5 multiplied 3, -15. -15 minus 6 equals -21. Multiply -1, we have 21J. Also the component in the direction of K is 7. So this is the first required. Second required is to find the length of perpendicular. It's equal the magnitude of the moment about B over the norm of the force F, equals the norm of the moment about B. It is square root of 0 square plus 21 square plus 7 square. because the component in the direction of I not exist, it's equal 0, so we write 0 square. The component in the direction of j is 21, we write 21 square. The component in the direction of k is 7 square over the component over the norm of the force F. The three components of F are 2, -1, and 3. So we write 2 square plus -1 square. We write -1 square plus 3 square plus 3 square. And the result will be root 35. Question 17. AB is a rod of length 60. We draw AB of length 60. 30 plus 10, 40 plus 20 equals 60. And weight 400 gram weight. Its weight is 400. Acting at its midpoint. So we have BO equal OA, H equal 30 at the midpoint. Rests on support 20 centimeters distant from A. This is a support at distance 20 centimeters from A. So we have a reaction of the support at the point C, denoted by the symbol R. The rod kept horizontally in equilibrium by a light vertical string connected to B. Here is the string connected to B. So the second force upward is the tension at B, the tension of string. It is equal T. Connected to B. Find the magnitude of each of the tension T in the string, and the reaction of the support is R. So the first required is to find the tension in the string and the reaction of the support R. We know that T plus R equals 400. T plus R equals 400. It is the first step. Then we take the moment about any point. It will be equal 0 because the rod is in equilibrium. So the sum of moments of all forces equals 0 about any point. Okay, let us write it. R plus T equals 400 and MC equals 0 because the rod is in equilibrium. Here is the point C. Of course, the moment of the reaction equal 0 about C because the line of action of R passing through the point C. So the moment of R about C equals 0. And the moment of 400 about C equals positive 400 multiplied 10. Note that the direction of rotation of the force 400 about C, it is anti-clockwise, minus T multiply 40. Minus T multiply 40. Why minus? Because it is clockwise. The direction of rotation clockwise about C. So MC equals 0. That means 400 multiply 10 minus T multiply 40 equals 0. Calculating to find T. We have 40. T equals 4000. Dividing both sides by 40, we have T equals 100. But R plus T equals 400, so we can deduce from 1 that R equals 300. From 1, R equals 300 gram weight. The second required is the magnitude of the weight that should be suspended from a weight suspended here from A to make the tension in the string is about to vanish. Again, the required number 2, what is the value of the weight must be suspended from A to make the tension at B equals 0. So we consider this weight equals W. So the tension in the string is about to vanish. It means T equals 0. So MC equals 0. 400 multiply 10 minus W multiply 20 equals 0. 400 multiply 10 minus the required weight here, its moment about C equals W multiply 20, but in negative sign because the direction of rotation of this weight here is clockwise. So 400 multiply 10 minus W multiply 20 equals 0. And then we can calculate it to get W equals 200 gram weight. Question number 18. ABCD is a rectangle. ABCD is a rectangle in which AB equals 9 centimeters, AB equals 9 centimeters, BC equal 12, BC equal 12. This is the dimensions of the rectangle. And an isosceles triangle HAD, it is isosceles triangle. It means HA equals HD. That is the meaning of isosceles triangle. Is drawn outside this rectangle such that AD is its base. AD is the base. And its height equals 8 centimeters. Height. HE is the height. Its length equals 8 centimeters. Forces of magnitude 36, 48, 36, 40, 40 gram weight act along AB, AD, CD, DH, HA. So the forces, the first force 36 acts at AB in the direction of the ray AB. Where is AB? We have AB and the force of magnitude 36 acts at AB. Second force is 48, acts in the direction AD, in the direction of this arrow. 36 acts in CD. CD, we have the force 36 acts at CD. The force 40 in the direction of DH. The force 40 acts in the direction HA. Prove that this system of forces is equivalent to a couple, then find its moment norm. So the required to prove that the system of these forces form a couple, and the required to find the moment norm, its norm. First, to calculate the length of HA. HA, note that HA equals HD. HA equals HD. So what is the length of HA? Using the Pythagoras theorem, we have HE equals 8 centimeters and EA equals 6 centimeters. So HA equals square root of 8 square plus 6 square. So HA equal 10, and we can deduce that AH equals DH equals 10 centimeters. There is a proportional between the forces and the sides on triangle HAD. 40 divide 10 equals 4. 40 is the magnitude of the force over the length of HA. 40 over 10 equal 4. Also 48 over the length of AD, which equal 12. So we have 48 divide 12 equals 4. Also 40 divide 10 equal 4. So the magnitude of the forces proportional to the side length of the triangle, and the three forces 40, 48 and 40 are in the same cyclic order. So the three forces 40 and 48 and 40 form a couple. So we write it 40 over 10 equals 48 over 12 equals 40 over 10, each equal 4. So, and we can write it, the magnitude of the force representing the unit length is equal to 4 gram weight, and it's equal in 3 cases. And since the forces are taken in one cyclic order, then the system is equivalent to a couple. The system of the three forces 40, 48 and 40 of magnitude equals negative. Why negative? Because it is anti-clockwise. The direction of rotation is anti-clockwise. Equals negative, okay, negative 4, we write 4 multiply twice the area of this triangle, multiply twice the area of triangle HAD. What is the area of triangle? It is half multiply base multiply 12 multiply height multiply 8. So we have the norm of the moment equals negative 4 multiply the moment equal negative 4 multiply 2 multiply half multiply 12 multiply 8, which equal negative 384 gram weight centimeters. The two forces 36 and 36 form a couple. Why? Because the line of action of these two forces are parallel. The two line of actions are parallel and in two opposite direction, and they are equal in magnitude. So the two forces 36 and 36 form a couple whose magnitude equals 36 multiplies the perpendicular distance, 36 multiply 12. What is the sign of this moment? The sign will be negative. Why? Because the rotation direction of the moment is clockwise. So we write negative 36 multiply 12, which equal negative 432 gram weight centimeters. So the system of forces is equivalent to a couple whose magnitude, whose norm equals negative 816. By adding the moment of the first couple plus the moment of the second couple, we find that the norm of the couple equals negative 816. Question 19. A ladder AB of weight 35 kilogram weight. Draw it. A ladder AB of weight 35 kilogram weight, 35 kilogram weight, and length 3 meters. So the length of the ladder equals 3 meters. Rests in a vertical plane with the end B on a smooth floor. So the end B on the floor and A on a vertical smooth wall, and A against a smooth vertical wall. The lower end B is attached by a string to a point on the floor vertically below A. This point is Z, and we have the string is BZ, and the tension in the string denoted by the symbol T. Okay, given that B is 1.8 meter away from the wall, B is a distant 1.8 meters from the wall, from the point Z. So we have BZ equals 1.8, and the weight of the ladder is acting at a point on the ladder 1.2 meter away from B. So the distance OB equals 1.2 meters. Find the tension in the string. Calculate the tension in the string. Also find the tension in the string when a man of weight 80 kilogram stands at the midpoint of the ladder. So we have two requirements. Before the man stand on the ladder, we want to calculate the tension in the string, and after that we calculate the tension in the string when a man is standing at the midpoint of the ladder. So let us start to find the tension without the man, the tension in the string without the man. First to calculate AZ equals the square root of 3 square minus 1.8 square. AZ equals 3 square minus 1.8 square. Note that measure of angle AZB equal 90. So using Pythagoras theorem to find the length of AZ. So AZ equals 2.4. R2 equals 35. We have R2, the vertical forces, R2 and 35. We have only two forces. R2 acting upward, perpendicular to the floor, and vertically the weight of the rod. It's 35. So R2 equals 35. It is equation 1. T equals R1. T equals R1 because the rod is in equilibrium. So the horizontal forces are equal. T equals R1. By taking the moment about B, here, the moment of all forces. Of course, the moment of R will be 0, and the moment of R2 equals 0, and the moment of the tension also equals 0, because the line of action of R2 and T passing through the point B. So what is the moment of 35? What is the moment of R1? The moment of 35 equals 35 multiply the perpendicular distance. Perpendicular distance is XB. What is the length of XB? this perpendicular distance equals 1.2 multiply cosine theta, considering the angle between the ladder and the floor here equal theta, and the R1, the moment of R1 is R1 negative R1 multiply AZ. What is the length of AZ? It will be 3 sine theta. It will be 3 sine theta. And we can use AZ from the beginning. It is equal to 2.4. So MB equals 35 multiply 1.2 cosine theta. 1.2 is the length of AB, minus R1 multiply 3 sine theta equals 0. 35 multiply 1.2 cosine theta equals 1.8 over 3. Cosine theta equals 1.8. 1.8, it is BZ over 3, adjacent over hypotenuse. 1.8 divide 3, it is cosine theta, equals R1 multiply 3 multiply 2.4 over 3. 2.4 over 3 is sine theta. Opposite over adjacent. Sine theta equals AZ over AB equals 2.4 divide 3. By dividing left hand side over 3 multiply 2.4 over 3, we get R1 equals 10.5. So R1 equals 10.5. Then we can deduce that T also equals 10.5 kilogram weight. And this is the first required. Second required in second page. When a man, this man of weight 80 kilogram weight, stands at the midpoint of the ladder. So what is the length of EB? It will be 1.5. What is the length of AE? Also equal 1.5, because the length of the ladder AB equals 3. We want to calculate the tension once more in the string. R2, the moment of R2 about B equals 0. Also the moment of T about B equals 0, because both the line of action of them pass through the point B. So we have three forces, 35, 80, and R1. The moment of the force 35 about B will be positive. Will be positive 35 multiply XB. Again, XB equals 1.2 cosine the included angle. The force of 80, its moment equals positive 80 multiply YB. It will be 1.5 multiply cosine theta. YB equals 1.5 cosine theta, negative R1 multiply AZ, and AZ 2.4. So MB equals 0. It means 35 multiply XB, again 35 multiply XB, plus 80 multiply YB minus R1 multiply AZ equals 0. 35 multiply 1.2 multiply 1.8 over 3 plus 80 multiply 1.5 multiply 1.8 over 3 minus R1 multiply 24. XB equals 1.2. XB equals 1.2 cosine theta. Cosine theta equals the adjacent, it is 1.8 over the hypotenuse equal 3. So we have xb equals 1.2 multiply 1.8 over 3 plus 80 multiply b. yb, what is the length of yb? It is 1.5 cosine theta, and cosine theta equals, we deduce it from the triangle ABZ, equals BZ 1.8 over 3 minus R1 multiply AZ. Why minus? Because the direction of rotation of the moment of R1 will be clockwise, so it will be negative. So it will be negative R1 multiply 2.4. By simplifying and calculating, we can deduce that R1 equals 40.5 kilogram weight. From the moments from this equation, we can deduce that R1 equals 40.5. But R1 equals T. R1 equals T. Only we have the two forces horizontally, R1 and T. So R1 equals T. R1 equals 40.5 kilogram weight, then T equals 40.5 kilogram weight in second case. Question 20. A uniform fine lamina in the form of an isosceles triangle ABC in which AB equals AC, AB equals AC, and AD is the height of the triangle. AD is the height of the triangle of length 45. The length of AD equals 45. A straight line is constructed parallel to the base BC. We have here a straight line. EF is drawn parallel to BC and passed through the center of gravity of the lamina. EF passing through the point X, such that X is the center of gravity of the lamina. To intersect AB and AC at E and F. So the straight line drawn intersect AB at E, AB intersected at E, and AC intersected at F. Prove that the center of gravity of the quadrilateral EBCF, the required is to prove that its center of gravity lies on AD and at distance 7 from the point D. At 7 from the point D. First, we want to deduce the center of gravity of the lamina ABC. The center of gravity lying on the point of intersecting of its medians. This point is the center of gravity of triangle ABC, and it is divides AD. This point divides AD by the ratio 1 to 2 from the base. So XD equals 1/3 AD. The length of AD is 45. It's from the given. 1/3 of AD equals 15 centimeters. And we can deduce that the center of gravity of triangle ABC is the point 0 and 15. Here, the point here is 0 and 15. Taking x-axis and y-axis, and D is the origin point. So the center of gravity with respect to the two axes dx and dy is 0 and 15. 0 and 15. Also, the center of gravity of the lamina AEF lies, or you can say it is the point of intersecting of its median, of its three medians, and dividing it by the ratio 1 to 2, 1 to 2 from the base. So we can say OX equals 1/3 AX, and OX equals 1/3 AX. 1/3 multiply 30 equal 10. Equals 10. So OX equal 10. Equal 10. With respect to D, so the center of gravity of the lamina AEF is the point 0 and 25, because 10 plus 15 equals 25 vertically. So we calculate AX equals 1/3 AX, which equal 1/3 by 30 equal 10. So the center of gravity of triangle AFE equals 0 and 25. We have a uniform lamina, so the area of triangle AEF over area of triangle ABC. Here we have two similar triangles, AEF and ABC. So from similarity, the area of triangle AEF over area of triangle ABC equals the ratio between the height of AX over AD square. It's equal 30 over 45 all square. 30, it is the height of AEF, over 45, it is the height of triangle ABC. So the ratio between the area of the small triangle and the area of the big triangle as the square of the ratio between their heights, AX over AD all squares. 30 over 45 all square, which equal 4 over 5. So if the mass of triangle AEF equals 4K, then the area of triangle ABC also equals 9K. Equals 9K. Then let mass of triangle AEF equals 4K and the mass of triangle ABC equals 9K. K is a constant. Then using the negative mass method by subtraction, we can deduce X equals, X is a component of center of gravity of the trapezium EBCF, equals 9K multiply 0 minus 4K multiply 0 over 9K minus 4K. So the result will be 0. And Y, it's the coordinate of gravity, center of gravity of the quadrilateral, equal 9K multiply 15 minus 4K multiply 25 over 9K minus 4k. Again, 9k, it is the mass of the triangle ABC. Multiply the component of its gravity. It's 15. Minus 4k, it is the mass of triangle AEF. Multiply 25. Y coordinate over 9k minus 4k. By simplify, we get y equal 7. So the center of gravity of the figure EBCF equals 0 and 7. So it lies on AD, here, and is at distance 7 centimeters from D. 7 centimeters from D. So the center of gravity of EBCF will be at this point here and at distance 7 centimeters from D according to the required.